Pick, I think it's DS for statistical displays. 401, collecting and presenting data. A lot of this is revision of last year. Categorical data is not numerical data. It's the opposite. It's data that's represented by categories, and it's usually words or symbols. There are two types of categorical data. We've got nominal data and ordinal data. Ordinal sounds like ordered, so ordinal data can be ordered, such as shirt size, small, medium, large. Other things that could be ordered that are categorical data would be if there was a question that says, you know, rate this from whether you like it, dislike, strongly dislike. Okay, you could go from strongly dislike to neutral to like greatly like, or whatever. So that would be something that you can order. Okay. Nominal data is a type of categorical data, and it's data that can't be ordered. For example, colors can't be ordered, the type of pet you own cannot be ordered, things like that are nominal data. Quantitative data, so they're quantities. They are represented by quantities or numbers, and there are two types of quantitative data. We've got discrete. Discrete means like individual, or continuous. So discrete data can be counted. For example, how many pets do you have, number of computers in the school. But continuous data you have to measure on some sort of scale, like a ruler, so length, height, the weight of something, that's on a continuous sort of scale, temperature, all of that you would read off and see where your value lies. I know you might say, but that's not the case with digital. But with digital, it will round to the nearest 0.1 or whatever. If you're weighing yourself on a scale and it goes up by 0.1s, the digital scale, you might be closer to, I don't know, 65.1 instead of 65.2 or something. So it'll round down. But that is anything on a continuous scale, like length, height, temperature, weight. Okay? So that is continuous data. Now, you've seen all the different data types over the years, but certain types of data are best represented in certain types of graphs. So categorical data you would not use a line graph for, all right? Categorical data is best in a column graph, which is like this one here. So that's a sideways column graph. You can have them up and down. Notice there are gaps between them. See, these are categories: grey, blonde, what color hair, for example? Grey, blonde, brown, black, red. How do you get to school in a divided bar graph? Do you walk, go by train, car, walk, cycle? They're categories. Notice they're in a divided bar graph. Or, for example, here, the days of the week. They might be asking a question about which particular day of the week do you do this. So days of the week in a sector graph. So they're all categorical data: divided bar graph, sector graph, column graph. However, quantitative data, so quantitative discrete, that's numbers, whole numbers. So whole numbers are best displayed in a column graph, or for small data sets we can use a dot plot or a stem and leaf plot. So these are for individual numbers. So in this stem and leaf plot we've got the number 03, which is 3, 5, number 12, 16, 17. Here's our dot plot. The number 5 occurs twice, etc. And here is our column graph, because there is more data here. The number 1 occurs 6 times, the number 2 occurs 3 times, etc. This is numerical data. We're graphing the data that we've collected. They're numbers and they're discrete numbers. However, if you've got quantitative, so numerical data that's continuous, it's best to display that in a line graph or these radar charts. Okay, now we looked at line graphs and radar charts last year. We're going to look at them this radar charts again this year, but the difference with HSC data is that you're comparing two sets of data displays as opposed to one, just looking at one. Okay, so quantitative continuous data, radar chart. Notice it's the one with the lines, or a line graph. Have a go at the state whether, so this is still revision of prelim. Is the following data categorical nominal, categorical ordinal, quantitative discrete, so numbers, whole numbers, or quantitative continuous, something that you measure? Okay, look at the first one. Temperature of water in a swimming pool. The number would be some sort of, the answer would be a number, but do you read it on a continuous scale? Temperature. You don't count it. Guys, who's got the little ducky thing in the pool? And you look it up and you try and decide, is the temperature of the water 26 or 28 degrees? It is. What sort of data? It's quantitative. Is it discrete or continuous? What do you read temperature on? A scale. It's continuous. It's not counted. You do not count temperature. You read it off a scale. Okay, star rating of a washing machine. You know how there can be 1 star, 2 stars, 3, 4, 5. Very tricky one. The star rating of a washing machine, I know you can have 1, 2, 3, 4, 5 stars, but it does measure how energy efficient the machine is. So 1 star means not very energy efficient. Do you know what I mean? 5 star means it's very energy efficient. So it is sort of putting them into categories, but the numbers are defining the categories. So we're going to go categorical, but we're going ordinal because you can put it in order. The higher the stars, you can go from 1, 2, 3, 4, 5. Really tricky one, that one. Okay. All right. So the number of people who voted for the Greens. This is, you'll give me an answer, wouldn't you? And you're counting people. Quantitative, it's a number. And discrete. Quantitative, discrete. So remember, quantitative is your answer if your answer is a number. And if you count, for example, the number of people, you're counting them, that's discrete. But if you're measuring off a scale, that's continuous, quantitative, continuous. Response time, when a patient's reflexes are tested, how do you check the response time? On a stopwatch or something like that. So this is definitely quantitative, but is it discrete? Do you count numbers? You don't go 1, 2. It's honest. Time is measured. It's continuous. Quantitative, continuous. The reason response time is continuous, it's because, yeah, you might measure to the nearest second, but someone else could measure to the nearest 0.1 of a second. Someone else could measure to the nearest 100th of a second. That is a continuous scale. It's not like when you're counting people. 1, 2, 3, 4, 5. There are when there are different limits of accuracy, like different accuracies. That's continuous. It's definitely on a continuous scale. A breed of dogs. Categorical. Can you order the breed of dogs? No. Categorical, nominal. Categorical, nominal. You cannot order dog types. We know you've got small and big, but you can't order dog types. Okay? It's like you can't order colour of hair. You can't order makes of cars. Categorical, nominal. A question that you may be asked as part of some other question. The type of display, describe the type of data displayed, and what is the strength of using these types of displays for those types of data. So question 3, what is the type of display? What's this one called? Is it what type of graph is it? Yes, it's a column graph. So it's a column graph. What type of data do we have?
Categorical.
Yeah, it's categorical, but what type of categorical?
Nominal.
It can't be ordered. Well, okay. And comment briefly on the strengths and weaknesses of the display. So, of this would be that it's very clear. You can clearly see alcohol is the most widely used drug by Australians, and that these others like heroin is the least. All right, so it's very clear. Okay. Interpret. Easy to read or interpret. Okay. But what's the weakness? Well, you sort of got to approximate values. Okay. You cannot read exact percentages. So cannot read exact percentages. So you can't read exact percentages off. Okay. But, you know, you can pretty much get the picture. For example, with this sort of looking at the drugs used by Australians, you would never do that. You would never display that data on a line graph. It could be displayed on a column graph. It could go into a sector graph. It could go into a divided bar graph, but definitely not on a line graph, not on a radar chart, because those types of graphs are for continuous data. This is categorical data, remember, is best displayed in a column graph, a sector graph, a divided bar graph, okay? Hey, this one, what type of display is this? Workers who completed year 10, they're just showing a profile of the population that they've surveyed a number of people. Graph, let's just look at the strengths and weaknesses of the line graph, okay? This is not the most typical thing that you would put in a line graph. Normally you see temperature over the year and things like that, sales figures over the year, but often not. These are almost categorical, almost. So what would be a strength? I suppose you can see the trend quite clearly. So a strength, I'm just going to do part 3, is that you can see the trend easily, and a weakness might be that you do not see the exact ages. Oh, I'd say you don't see the exact ages because they're in groups.